Problems like this are really important when you're learning new techniques of differentiation, and that is, take problems that look very similar but are actually done quite differently. So for example, this one is saying the outer function is tangent inverse, so take the derivative of tangent inverse. So you've got the derivative with respect to x of tangent inverse, if it was just an x, would be 1 over 1 plus x squared. Well, instead of an x, we've got a y squared. So this is saying whatever you've got right there, you've got to square it right there. So we're actually going to get 1 plus y to the fourth. So it's going to be, we've got to take the derivative on both sides. So the derivative of x is going to be 1 equals the derivative of tangent inverse is 1 over 1 plus the argument squared. So y squared squared is going to be to the fourth. And then the chain rule says take the derivative of the inside function. So take the derivative of y squared, which is a 2y, and then you have to take the derivative of y, so that's y prime. Now I need to solve for y prime, so take this 1 plus y to the fourth and multiply it onto the other side. And then finally divide both sides by 2y, and y prime is equal to 1 plus y to the fourth divided by a 2y. So it turns out that y prime is a function of y instead of x. And then for this one, this is saying again tangent inverse, but this is saying that the y is going to be squared. And this one says that the y is squared. And this one says that the y is squared. They're actually the same. And then with this one, it's saying that the tangent is squared. Okay, so this is saying you've got tangent of y inverse, and all of that is being squared. So the outermost function is the squaring function, so take the derivative of that first of all. Again, the derivative on this side is going to be 1, and then the 2 goes down in front, and the tangent of y to the negative 1 stays there. Now the next innermost function is tangent, so we need to take the derivative of tangent. The derivative of tangent is secant squared. And then finally take the derivative of the function that's inside there, y to the negative 1. So that's going to be negative 1 gets brought down and multiplied with y, and then subtract 1 from the exponent, so it's to the negative 2. And then the innermost function there was a y, so we need to take the derivative of y, which is y prime. Wow. So to clean that one up, I need to get rid of all the negative exponents. I'll do that first. So another point with this one is that we use the negative 1 exponent in two different ways. When it's on trig functions, it means that it's the inverse function. So in fact, sometimes you'll see this. And what they're doing is they're trying to get away from using the negative 1 exponent. But it's just so much faster to write it. We have sort of gotten away from saying arctan, but that's what it means, the inverse tangent function. And then in algebra, it means invert whatever you've got, like in here, invert the y. Okay, so that's that one. Then we've got secant squared of 1 over y. And then we've got a negative, which I'm going to move to the front, negative. And then a y prime on top and a y squared in the denominator. And then to solve for y prime, multiply by y squared. And finally, divide by the tangent and the secant. So we'd have y squared gets divided by, so divide by all this stuff, leaving the y prime by itself over here. So negative 2 tangent of 1 over y and secant squared of 1 over y.